taking a look at section 3.8, we are dealing with slope. Now, there are some aspects here that we are not going to worry about, okay? I'm trying to lead us into what we're actually going to be using this for in 6.7, okay? So some of the notes here we're not going to cover, but I do think there are some very important things that we need to know. And first off, which, let me double check here. First off, something that is not given to you on here, I think it was just something that was expected that you remember, honestly, is what the heck is slope? So somewhere on this page, I'm going to tuck it up in here. I want you to write down a couple of things for me. So slope. Another measure, or another way we talk about slope is the variable for slope. And the variable for slope is pretty much universal, okay? At least when you're down in the, I'm going to call it the lower math. Okay, lower math being everything from calculus down. All right, so you think calculus is the higher math. Well, yeah, but there's also people that are crazy smart that do things far beyond anything I've ever done, okay? So in all those lower maths, calculus down, m is the variable we use for slope. Okay, m is the variable we use for slope. I don't know why. I don't know why they don't use s. Maybe it's because it looks like 5. I don't know why. Okay, but m is what we use for slope. And then slope, what is that? What does that mean? Anybody happen to remember what slope means from Algebra 1? It's rise over run. And I'm going to write it this way, but that's not always the way I think of it. So first off, a slope is a fraction. It's a ratio, okay, of the rise to the run. And just as a comparison, that is actually something that people use all the time in houses, okay? In the roof of a house, they have what's called a pitch, okay? And the pitch of a house can be anything from like a 4/12 pitch, a 6/12 pitch, you can have a 14/12 pitch, something that's really steep, okay? Well, what are they talking about when they say those numbers? They're talking about the slope. They're talking about the rise over the run. How many inches does that roof go up, the slope of that roof go up, for how many inches does it go across? Okay, so a 4/12 pitch, I'll do it up on the screen here, a 4/12 pitch is going to mean that it's going to rise 4 inches for every 12 inches that it goes across. And so your 4/12 pitch is going to be a shallow roof that doesn't really have much of a slope to it. Okay? Versus a 14/12 pitch, which means it goes up 14 for every 12 it goes across. That's going to be a much steeper roof. All right, so slope is something people talk about. Okay, don't ignore this stuff. This stuff actually shows up all the time. And why does it matter to you? You might be thinking, well, hey, I'm never ever going to be a roofer. You may never put a shingle on a roof in your life. But someday you might own a house and have to get that house reshingled. And guess what? A 14/12 roof costs a lot more to get reshingled than a 4/12 roof. Why? Huh? It's harder to do this one. This one's really steep and dangerous, especially if you have a multi-story house where these guys have to stand up here, 30 feet off the ground and try to put shingles on that thing, okay? Whereas a 4/12 roof is fairly safe to walk around, okay? So this matters. You want to know these things. All right, so slope. M is the variable we use. It's rise over run. What is it? It is a measure of steepness, like I was talking about with the pitch of a roof. Okay, it's that measure of steepness of that roof. Rise over run. I remember it as wise over run. Why? Because I'm clever and it rhymes. Okay? It's wise over run, not rise over run. Why? Why change it that way? Because there is an equation that allows us to solve for the slope. If we're given the coordinates of points on a line, we can say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That will give us the slope. That right there is called the slope formula. Okay? So I say y's over run, not rise over run, because you got to remember that in the slope formula, the y's go on top. That's a big deal because in our coordinates, the x comes first. And so it's natural for people to want to put the x on top. And then they wonder why they get their problems wrong every time. It's not because x's go on top, it's y's go on top, right? Okay, so we have y's over run. Things, questions on that. Kind of remember talking about this Algebra 1? Whether you actually remembered the formula or not isn't the point, but you remember doing this? Okay, slope-intercept form, just FYI, we're not going to do it right now, but slope-intercept form is the equation y equals mx plus b, where m is the slope, where b is where it crosses the y-axis, so where it crosses that vertical, so that's just a number, it crosses it at 2, let's say. And then x and y stand for the coordinates of every single point on that line. All right? If we have more time, I can go through some of that, but we're not going to use that in geometry right now. You guys will definitely see that again in Algebra 2, though. Okay? That will come back and rear its head in Algebra 2 quite a bit. So that is slope. It's that measurement of rise over run, or y's over run. So a few things that we need to know. For this class. We have talked about parallel lines in here. We've talked about perpendicular lines in here. But now if we start talking about the coordinate plane, the xy axis, and doing this algebra involved, we also need to know a few things, such as non-vertical lines. So two lines that do not go up and down. Non-vertical lines are parallel. If they are parallel, then their slopes are equal. Okay, their slopes are equal. Means the value we find. They say they have a slope of 1/2, then the other one has a slope of 1/2. They're equal if they're parallel. If slopes have two distinct non-vertical lines are equal, then they are parallel. So these are kind of like converse statements. If they're parallel, the slopes are equal. If the slopes are equal, then they're parallel. And then the last one is any two vertical lines or horizontal lines are going to be parallel. That's two separate statements. I don't know why they put them in the same statement like that, because that can be confusing for people. Two vertical lines, those are going to be parallel. Two horizontal lines, those are going to be parallel. They are not saying that one vertical and one horizontal are going to be parallel. Because what's going on there? Those are going to be perpendicular, right? We've talked about that. Okay. So looking at that then, let's go ahead and talk here. So we have 4 types of slope that we need to be able to identify. Just by looking at a graph, you got to be able to tell me that line has this type of slope. You're not going to be able to tell me just by looking at it without counting or doing some other stuff what the slope is, but you should be able to identify the basics. Meaning, you should be able to identify negative slope. Bless you. You should be able to identify negative slope. And before we get into this too far, I mean, you guys are in black and white. Mine's in black and white. It's kind of hard to see all these lines going on. This is, I will make it a little bigger on mine, and then I'll do the other ones in color. This is the y-axis. This is the x-axis. Okay? And so those other lines are what we're talking about. So we have the y-axis and the x-axis there. The other lines are what we're talking about. And a negative slope Think of it like a graph of like the stock market. You guys ever watch the news and see kind of the graph of a stock market and it kind of jumps around, da 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 da. Okay. Well, when they have really good days, which way is that graph going? It's going up. As time goes on, as time goes to the right, the graph goes up when we have a really good day, right? What happens when we have a bad day? Goes down. Well, would you describe a good day in the stock market as negative? No, that doesn't make any sense. That's a positive day. Bad day on the stock market, that I could describe as negative. And so guess what? The slopes of a line look the same way. A negative slope is going to be going down when you travel from left to right. So think of the x-axis as time. As time moves forward, the graph goes down. And so that would be like line J. All right. A positive slope would be like line K. All right. That's a happy day on the stock market. Okay. Well, that's a graph of my bank account on payday. Okay, all of a sudden it shoots up. So that is line K. Undefined slope. Undefined slope. It's kind of an odd one for people to figure out. So before we talk about undefined slope, I want to talk about zero slope. Zero slope very literally means m equals 0. Okay? M. What was m? Slope. It's a value. It's a number. We can use that equation to find it. M equals 0. That's what slope of 0 or zero slope means. Okay? So, if you have zero slope, think of that roof. Think of that roof. A zero slope roof, a zero pitch roof, it's flat. That's why you're just about to make that gesture, right? It's flat. The floor we're standing on is flat. It has a slope of 0. We're not worried about sliding off the floor. Okay? So, looking up there, which line looks like a flat roof or like the floor? L, exactly. And so right here is zero slope. Line L. Whereas undefined slope, again, that's the one that's kind of hard for people to figure out. But the way I like to think about it, it's called undefined because it is so steep, we just can't comprehend it. Okay? It's so steep, we can't comprehend it. Well, that is, and of course, by process of elimination. You guys know I'm talking about line N. Line N is a vertical line. Line N is a vertical line, and so we say it has an undefined slope. Okay, now another reason why it's undefined. Is because if you're looking at the slope formula, an undefined slope is going to be where you get some value when you take y sub 2 minus y sub 1, but then when you take x sub 2 minus x sub 1, you get 0. Can I divide by 0? No, I can't. It breaks the laws of mathematics. You cannot divide by 0, and so therefore, that would be undefined. Which means we have a vertical line. Okay? That's what that's going to look like. So what I'd like you guys to do is I would like you guys to take a moment and try to find the slope of line A and then the slope of line C in this diagram. Be careful, find your coordinates, find your lines. Please use the slope equation, find the slope of line A and the slope of line C. Ready, set, go. Taking a look at line A. First off, pay attention to the fact that line A is this line here. you got to look for points that we know on that line. Hey, we know a point right there. They're pointing to it saying that's at 4, 6. Another point right here, they're saying that's at 0, 2. We need those 2 points to find the slope of line A. So I'm even going to highlight those 2 points. That one and that one. Okay. So what I'm going to do then is use my slope formula. So my slope is going to equal y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So therefore my slope is, well, what's my y sub 2? What's the y coordinate of the second point? 6. Sure. 6 minus, what's then y sub 1? 2 over x sub 2. 4. Yeah, because remember, if I started out with the 6, I got to then go back to the 4, right, as my second point. Minus 0. One thing to pay attention to is when you look at the slope formula, if you look above and below like this, those numbers should come from the same point. Okay? The 6 on top and the 4 from the bottom are the x and y coordinate of the one point. If your coordinates ever crisscross, you're wrong. All right. So we have this, therefore, 6 minus 2 is 4. 4 minus 0 is 4. So our slope must be 1. That's all we're doing. That's all we're doing. Find the slope of line C. Well, looking at line C, I see it has this point on it. It has this point on it because line C is this line here. Well, hey, just looking at that, what should we be able to tell?
It's going to have a 0.
And say, so the floor is so steep that we just can't comprehend how steep it is? No, it's 0. It's 0. It's not steep at all. It's got a slope of 0 on this. And so let's just see real quick. I'm showing you what that looks like on the equation. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Notice we get 0 over 4. Can I take 0 and divide it among 4 people? Yes, I can. I am a generous teacher. Here you go. I have nothing. You 4 can each evenly have nothing. You're welcome. Happy birthday. Okay? Yeah, I can divide 0 by 4 people. They don't get much. They get 0. But I can do it. It makes sense to do it. Okay? So this gives me a slope of 0, which is a horizontal line. Okay? Don't get that confused with dividing by 0. Dividing by 0 is a very different beast. Dividing by 0 is like having having 3 pens and dividing it among no people. Who gets the pens? See, now you said, I do. I'm a person. So that's dividing by 1. I get the pens. Dividing by 0 doesn't make any sense. There's nobody there to receive the pens. Okay? So you can't divide by 0, but I can take no pens and divide it among people. Everybody gets nothing. I can do that. That makes sense. Okay? All right. So, questions on slope formula? No. So, we know that if 2 lines have the same slope, then they are going to be parallel. Well, perpendicular is a little different. If 2 lines have what I call opposite reciprocal slopes, then they are perpendicular. Opposite reciprocals. First off, from Algebra 1, what does reciprocal mean? Yeah, refliprical is what you think of it. So you flip the fraction. Yep. Opposite means you switch the sign. So, if I want to come through here and I want to say that I have a slope of 2/3, my perpendicular slope, the opposite reciprocal slope, would be what? That's the reciprocal. The opposite then means we flip the sign. -3/2. Now let me show you that. And I'm not going to even work this problem here. I just want to show you. Actually, here's my graph. I'll show you this. If I take a line, and let's say I'm going to go up 3/2, up 3/2, up 3/2, so on and so forth. There's my line. Oops, I got off there a little bit. All right. So there's my line. That has a slope of, notice my rise is 3, my run is 2. So if you have a graph that's graphed like this, you can find the slope by just counting it too. You don't have to do the formula. You can just count on the graph, rise and run. But if I say negative, let's see, I said rise over run, so 3/2. If I say -2/3, so my original slope was 3/2. Now I'm saying -2/3. If I count that from somewhere, let's say I count that from right here, down 2, right 3. That's what -2 means. Down 2, right 3. But slope is like stairs. I can go up and down stairs. Same thing with slope. I can think of this as -2/3, but it's the same thing as saying 2/3. So I can count the other direction. I can say I'm going to go up 2, but then left 3. Up 2, left 3. Up 2, left 3. It all gives me the same slope, and there's my line. Cool thing is, knowing my slopes, I then am guaranteed that this is a right angle, a perpendicular set of lines. Okay? Questions? No, we're quickly running out of time here, so I'm going to give you guys some homework. Okay, so I didn't get a chance to talk about this in class, but for those of you watching the video, this is your assignment, and those last 4 problems, 30 through 33, I'd like to go over an example, something like that. And so if you come down here on your notes, we have these guys. And what we want to do, let's just make the assumption, because this is going to be like your homework. Let's say that A, B, C, D is a quadrilateral, okay, which of course it would be. And we want to find out, is it a parallelogram? Meaning, are the opposite sides parallel? All right, remember that symbol means parallelogram. So is it a parallelogram? How are we going to know? Well, we don't really need graph paper to do this, okay? It might make it look nice on a graph paper, but really all you need to do is draw a quadrilateral. Doesn't need to look like a rectangle, but then just label your points. A, B, C, and D. So now to find out if we have a quadrilateral, or I'm sorry, a parallelogram, we got to determine, are these two sides parallel and are these two sides parallel? So we need to find the slope of AD. Let me get rid of those marks because we don't really know that yet. So we need to find the slope of AD, the slope of BC, the slope of AB, and the slope of DC. All right, so looking at AD, so we're using the A and D, it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1, making sure to be very careful looking across that to get the proper numbers. plus, so we have a negative 1/9. Okay, what if I do BC? So then I have 3 minus 11 over negative 1 minus negative 4. So that's going to give me negative 8 over 3. Let's keep going. Let's not wait here. AB, so we have 11 minus 3 over negative 4 minus negative 8. So that gives me 8 over 4, which is 2. And DC, we have 2 minus 3 over 1 minus negative 1, which gives me negative 1 over 2. Negative 1/2. So what does this tell me? Well, first off, it tells me that none of these sides are actually parallel. But I do know that these two sides are perpendicular. So AB and DC, AB here, DC, well, my drawing doesn't show that because AB and DC actually can't be perpendicular. But according to their slopes, they are perpendicular. So this is actually closer to what it should be. If I get rid of this, and I don't think I'm going to be able to flip those around, but sorry folks, my example fell apart here at the end. But those two slopes are then perpendicular, so my diagram's not going to work. But in your, this is the process you're going to have to go through for your last 4 examples in your homework. They're going to give you points. In the homework, of course, their points will work as a quadrilateral. You need to determine, do you have parallel sides for the opposite sides? I hope this helps. Hope this didn't confuse anybody. Have a good night.